Hi there, this is Soman and you're watching the Genesis YouTube channel. In this video, we'll be talking of thermometers and temperature scales. We'll be describing several different types of thermometers and we'll learn how to convert temperatures between the Celsius, Fahrenheit and Kelvin scales. Any physical property that depends consistently and reproducibly on temperature can be used as the basis of a thermometer. For example, volume increases with temperature for most substances. This property is the basis for the common alcohol thermometer and the original mercury thermometers. Other properties used to measure temperature include electrical resistance, color, the emission of infrared radiation, etc. Because a lot of physical properties depend on temperature, the variety of thermometers is remarkable. In this common type of thermometer, the alcohol, which contains a red dye, expands more rapidly than the glass encasing it. When the thermometer's temperature increases, the liquid from the bulb is forced into the narrow tube, producing a large change in the length of the column for a small change in temperature. In this picture, a firefighter uses a pyrometer to check the temperature of an aircraft's ventilation system. The pyrometer measures infrared radiation from the vent and quickly produces a temperature readout. Infrared thermometers are also frequently used to measure body temperature by gently placing them in the ear canal. Such thermometers are more accurate than the alcohol thermometers placed under the tongue or in the armpit. Thermometers measure temperature according to well-defined scales of measurement. The three most common temperature scales are Fahrenheit, Celsius, and Kelvin. Temperature scales are created by identifying two reproducible temperatures. The freezing and boiling temperatures of water at standard atmospheric pressure are commonly used. On the Celsius scale, the freezing point of water is 0 degrees C and the boiling point of water is 100 degrees C. The unit of temperature on this scale is degree Celsius, abbreviated degree C. The Fahrenheit scale has the freezing point of water at 32 degree Fahrenheit and the boiling point of water at 212 Fahrenheit. Its unit is the degree Fahrenheit or degree F. You can see that 100 degrees Celsius span the same range as 180 Fahrenheit degrees. Thus, a temperature difference of 1 degree on the Celsius scale is 1.8 times as large as a difference of 1 degree on the Fahrenheit scale, or delta TF is equal to 9 by 5 delta TC. The definition of temperature in terms of molecular motion suggests that there should be a lowest possible temperature where the average kinetic energy of molecules is 0, or the minimum allowed by quantum mechanics. Experiments confirm the existence of such a temperature called absolute zero. An absolute temperature scale is one whose 0 point is absolute zero. Such scales are convenient in science because several physical quantities such as volume of an ideal gas are directly related to absolute temperature. The Kelvin scale is the absolute temperature scale that is commonly used in science. The SI temperature unit is the Kelvin, which is abbreviated capital K, and note that it is not accompanied by a degree sign. Thus, 0 Kelvin is absolute zero. The freezing and boiling points of water are 273.15 K and 373.15 K respectively. Notice that in the Kelvin scale, the difference in the freezing and boiling points of water is of 100 units. And this is exactly the same as we had in the Celsius scale. Therefore, temperature differences are the same in units of kelvins and degree Celsius, or delta TC equals delta TK. These relationships between the three common temperature scales are visually shown in this diagram. Pause the video, study this diagram, notice how a 9 degree Fahrenheit change is the same as 5 degree C change or a 5 Kelvin change. Using this figure, you should be able to convert from one temperature scale to the other very easily. The equations to convert from one scale to the other are summarized in this table. Pause the video, go through this table, relate it to the previous diagram, and you should be able to work out these equations on your own. Let us take an example where we express the room temperature in degree Fahrenheit and in Kelvin. Room temperature is generally defined in physics to be 25 degrees C. What is the room temperature in degree Fahrenheit and what is it in Kelvin? To convert from degree C to degree F, use the equation Tf is equal to 9 by 5 Tc plus 32, substitute the known values and we'll get the answer as 77 degree Fahrenheit. Similarly, to convert from degree C to Kelvin, use the equation Tk is equal to Tc plus 273.15 to get an answer of roughly 298 Kelvin.